trigonometry or trigonometric auxiliary angle method. So express 5 sine x minus 3 cos x in the form r sine x minus alpha. So we use the compound angle formula for sine in the MF19. Since this is sine minus, we use the sine below. We gotta use sine cos minus cos sine. So that's what we do here. We use sine cos minus cos sine, and the square brackets are important here because we have to multiply r to both terms. And now we compare the coefficients on both sides. On the left, the variable is sine x, variable sine x. The coefficient on the left is 5. The coefficient on the right is r cos. That's why we have the first equation. And for the second term, we have cos x for the variable, and for the coefficient 3 on the left, r sine on the right, which means 3 equals r sine. And then we divide both sides, both equations. So r sine over r cos is 3 over 5. Of course, we cancel out the r. Sine over cos becomes tangent, and we do inverse tangent. We get alpha equals 0.54 in two decimal places. And to find the r, we can just square and add. So r cos, r sine 5, 3, because if we expand, or if we square, we get r squared cos squared, r squared sine squared, and we factor out the r squared. We have cos squared plus sine squared. And actually there's an MF19 formula in trigonometry. This is called the Pythagorean identity. Cos squared plus sine squared is actually 1. So this is 1. So that means we can just take the square root of both sides. We get r, the positive r. Hence state the greatest and least possible values of. Okay, so previously in the first part, we know that 5 sine minus 3 cos is approximately equal to this, which means if we square both sides, we have 34 sine squared, and the maximum value, or the value of sine whatever angle, can only be between -1 and 1. And if we square it, sine squared, it cannot be negative, so it's only between 0 and 1. So the value of this guy here would be between 0 and 34, which means the smallest value is 0 and the biggest value is 34. All right, I'll see you guys.